Andy Palmer. I'm the co-founder and CEO at Tamer, and I'm serving as track co-producer alongside my good friend JP Chavet for virtual track number 6. It's my pleasure to introduce the next session, the CDO's Toolkit, Machine Learning, Data Management, and Automation. And before we get started, though, I have a few housekeeping items. First and foremost, the session's being recorded. Any presentations will be included in the Symposium proceedings, and the video recordings will be updated to the CDOIQ YouTube channel 3 months after the Symposium. There'll be Q&A session at the end, so please submit your questions in the Whova app in the Q&A tab, and we will address them as we go along or at the end. And with that, let's get started. I've got 4 amazing panelists today, and I'll ask each of them to introduce themselves and give their background. And maybe Vanessa, start with you. Oh, unmute.
Of course. Thank you, Andy. Very happy to be here. Thanks for having me. So I'm Vanessa Gonzalez. I work at Transamerica, and I'm a senior director of data and analytics. I lead the advanced analytics, ML, and AI teams. I'm also part of the data and digital transformation that we're going through. And I've worked in financial services for a few years, and before that in higher education. So a couple of different industries there, but very excited to be here and looking forward to this conversation.
Excellent. Graham?
Graham Gordon. I work in the energy sector for Hess. I've been involved with machine learning and automation for the last 6 years. Before that, I used to manage various teams, commercial planning, strategy, portfolio, and before that on the subsurface side. So again, interested to participate in machine learning conversation.
Excellent. Mark?
Hey, everybody. I'm Mark DiGregorio. I spent 20 years at Staples in the retail sector, delivering on technology and data projects. My most recent role was leading enterprise analytics, data science, as well as architecture. I left late last year and working with a small technology company called KISS Solutions. And I'm excited to be part of this session. I think it's a great and important topic. So thanks for including me.
Terrific. And John?
Yeah, thanks, Andy, and thank you to the MIT organization for having us. I'm John Bottega. I'm the president of the EDM Council. We're a trade association that focuses on data management best practices, frameworks, standards, adherence to standards, important topics being discussed over the full 3 days. So happy to be here and happy to be on this panel.
Terrific. So the topic, is how machine learning is useful, and where it is useful, and maybe a really compelling question might be where it is not useful. I know I've talked to each one of you at various times about the fact that now that machine learning is so broadly accessible, you don't have to go any further than ml.lib. And there's so much compute available. There are a lot of people using machine learning to do a whole bunch of things. Some of them good and productive and useful. Some of them wasteful and distraction. And so would love to kind of go through and just get an initial take from each one of you as to where do you see machine learning being used productively and functionally? And are there examples that you see of people either wasting their time, building their machine learning skills, but not actually creating value, or trying to boil the ocean with machine learning. Vanessa, do you want to start?
Sure. So that's a great question, because machine learning, the beauty of it, I think, is that it can be applied and used in so many areas. And it's always and right now everybody's okay, let's use it everywhere. And it's not the best tool all the time. But what I can say is that what I've seen that has really good uses is where I would say when we cannot comprehend just with our own mind how to manage a lot of different variables at one time. So when you have to, when we don't have, we have a good intuition in our businesses of what is going to work and what's not going to work. But when we want to predict future behavior, when we want to predict the future action, and there's a lot of variables involved, I think that's a great application in machine learning. A good example is in to identify, for example, fraudulent transactions. We can tell in a fraudulent transaction about a couple of things that sometimes may tell us that it's fraud, but maybe it's not. But when you use a machine learning model and it's very well built, you can see that the combination of transactions, not just the appearance of them, but how they interact between them on the different variables in that transaction, that's what is going to really be very powerful using machine learning for. So that's just an example that can help us. And the other thing is that what I would say, it's not just using it, but also how do we integrate it with our business to find and really get solutions and for business problems. That's what I say, that the machine learning, it's very, very important when it's quite capable to do that. If we cannot solve business problems, it's not a great application of it.
Great. Graham, thoughts?
Yeah, so in the energy sector, one of the areas that we were targeting machine learning for was really about blending similar data types together. And I'm talking about something coming from vendor Y externally and X and Z. And so we were trying to kind of take attributes from one and blend it with another. And we were having problems when we did it just through normal business rules. We were getting 35, 40% kind of matching. But then when we started to do machine learning and push the boat, I was like a little bit of a naysayer going, this is not going to work, the black box, white box, gray box kind of scenario. How do I explain this to others? But then when I started working with subject matter experts and we started kind of thinking, well, how do we actually help the machine do machine learning? And what I meant by that is like you do transformations on columns before it actually goes into the model. And we saw much better uptake when we did that. So we had these helper projects and stupid things like date formats being the same and making sure that company names, it sounds like, you know, Hess has got Amrada Hess as a background. It's got all of these different entities around the world. How do you get those all blended into just being one name? And then helping that be a common column that can then go into blending those sources. So there's always these kind of helper projects that you can set up on the front end to actually standardize some of those columns to then help the machine kind of get a better output. And then we were starting to get over 95+% on the clusters that we were seeing on the front end and being able to mix and match attributes. So it's on that front end where people were starting to kind of understand what the output looks like and then gets confidence in trusting that data that then you get an uptick and saying, yeah, this can actually help in this space. So it's really that front end logic, making something easily accessible and actually have the data lineage back to see what the machine's actually doing. And then that black box becomes more white. So there's just a couple of examples.
That's great. Really, really terrific. Mark, thoughts?
Yeah, I think another factor, an important one, is scale, right? So the size of the information that you're actually working with, right? And the example that that we worked very closely with Tamara on is around our customer data, right? So we had hundreds of millions of records, first party to third party data that we were, leveraging a product that we're having to hand code the rules to be able to manage all the different permutations to be able to get the output that we were looking for. And we weren't really able to efficiently respond to the changes in the market as well as the needs for the business. So our ability to apply machine learning to scale to the volume of data and also the variety of different ways that the business was looking at the data. So I think, in customer being so essential to the retail industry was an important example. So that was just one example there.
That's great. Thanks. John, any thoughts?
Yeah, sure. One of the advantages of being a trade association with many members, you hear many stories from members, who give us their examples. And two quick ones that come to mind. One is using machine learning to improve business process management and business process efficiency. We live in a world where we're locked into legacy processes. Being able to take the steps in a business process, apply it to a machine learning model, it suddenly discovers things that aren't so efficient. And it neutralizes, if you will. This way, there's no politics, there's no, argument. It's just the facts of this process could be improved because of this, and that's one use. Another, which is really timely and something that the council has been involved in, is applying machine learning to the data supply flow from an ESG perspective in the fishery industry. We took a use case of data coming from fishing vessels and then added to it, taught the machine the policies, the rules, the laws associated with fishing in certain regions. And the engine was able to say, wait a minute, you're catching this species in this water. Not possible, because that fish doesn't run in that water at that time, or you're not allowed to fish in those waters because it's spawning season. So you can see just two great examples. To your question about what is it not, or maybe the when not to use machine learning, I think it's more about when not to use machine learning incorrectly. And everybody who's in the space knows that if a machine is just like a child. If you teach it good things, it learns good things. If you teach it bad things, it learns bad things. So from a data perspective, incomplete data can lead to inaccurate results, or even worse, unethical results. So, for people who are in the machine learning space, have to appreciate that the data as a factor of input is critically important to the accuracy of those responses. So it's that balance between the benefits and also just being aware of the risks.
Gotcha. So let's talk a second about explainability and the challenges sort of that are presented. And Mark and Graham, you both referred to this sort of idea or concept that using machine learning and a bunch of other processes around, like you can turn something that felt like a black box initially into something that was much more transparent and explainable. Graham, any thoughts on this? I mean, it's kind of a classic thing we hear all the time at Tamer, that people are like, machine learning, you don't understand who knows what's gonna come out the other end. And we don't really find it's like that. We kind of find that common sense tends to prevail. Yeah.
So I think, the way that at least we've done some of our kind of categorization on attributes, or we're looking at blending between sources. If you have an email that comes through to a subject matter expert themselves, rather than going into IT or the person that set up the project, and they get embedded in the workflow and they do little and often each day, then they can start to label these things themselves. So if you have on that email a confidence factor of what the computer thinks it is doing, then obviously concentrating on the lower confidence ones and upper ones. If you're seeing then themes coming out that need to, the machine is always getting wrong, then you can start to kind of mitigate against that. And I think that those are kind of some issues when you build a model at the start of a process, and then suddenly you get creep in the inputs, and suddenly you think that it's done. You have to maintain and make sure that you're kind of keeping on top of those things. I think to your point of gaining confidence, what I saw a lot of value in is when those emails are coming through and the computer's getting it right. And then they were doing it manually, and they were creating reports. I remember one on the drilling side, people drilling wells, and we had 6 rigs working, and suddenly all of those names were different. And so standardizing those and being able to do analytics on those, your downtime, where problems were, what was over budget, what was under budget, what should we be learning from this rig that we can apply to another rig. There's some learnings there that were very difficult to pull together. That was probably about 90% of 3 people's time. And then that goes all automated. So you can then transfer your time into actually doing analytics and getting insights. So you're transferring that, 60, 70, 80% of your data time of just compiling everything and manually doing it in Excel wizardry, to actually doing something in a BI tool and being able to become predictive and do a lot more on the analytics side. So once they gain confidence that the machine is actually getting it right a lot more of the time, then they get confidence in the output, and they actually do those labeling, see where there's problems in the model, feed back to the modeling expert, and then you've got the integration going on in a continued way. And that's really important for the results to be used, and maintain themselves going forward.
So the confidence you're saying sort of comes in practice as you're actually using the data and having the experience of working with the data.
Yeah, and feeding back to the model, you know, saying, hey, this is not picking this up properly. This machine is not doing it correctly. Why is it not picking up? I think I can see why it's not doing it. It's because of these reasons. And suddenly they start to think more like a computer rather than in their domain expertise. So it's when you work on projects like this, I think you have to have what I call some friendlies in the business that you can work with. But you also have to have some naysayers, because they can come back and really say, hey, this is rubbish there. But then suddenly when they start being repeat customers and coming back and saying, hey, Graham, can you help on this? Then you can see that they're actually doing stuff manually the old way again. And suddenly it becomes, I would say that one of the biggest plus points as well in any organization is to make sure that the actual data on the front end is live fed, that the duration and the applicability, you know, not getting a CD and getting it onto a drive, you know, everything's gone into the cloud and making it accessible. So having that update cycle of little and often every day, rather than just doing it when you need it, that means that subject matter expert time is then controlled in a way that makes sense, that they can input and see where your creep is occurring before a real big request is being made. So
very incremental and dynamic, and like in computer science, we call that an active learning system, right? A dynamic active learning system. Yeah.
Exactly.
Vanessa and Mark, any thoughts?
Yeah, I'll jump in if you don't mind, Vanessa. But I would say, you know, when you think about the black box, I do think largely is a perception based off of lack of knowledge or understanding, right? So there's just you know, when they don't understand the process, they assume, okay, you know, I have no idea how it's getting the results. But, you know, there's a lot of transparency that can be provided by just engaging with them. As Graham said, like engaging them with the process, right? Get them involved in the training, get them to understand some of the inputs into this. And I think explainability is an important aspect, right? So we can not only tell them the confidence, we can tell them exactly why the model came out with the result that it did, right? And the more transparency in their understanding of the role that they play in machine learning is an important aspect. I think once they feel more comfortable with how that process works and the role that they play, then it doesn't feel like a black box, and that trust and that confidence in machine learning as a tool can start to increase.
And just to add with what has been said, and I think Graham hit the spot about the collaboration with the business. There's like for a model that the implementation to be really successful is where we're going to have that trust, and that building of that trust is going to happen by a lot of feedback loops. It's going to happen about taking into consideration the expertise of our business and their experiences, and also have a lot already in your process, have places where you're going to be measuring success when possible, have a validation set, and have the business look at it and see, okay, here is where we're getting. And as Mark was saying, making sure that there's a way to explain why. I don't think anybody needs to understand exactly how different modeling techniques work, but what they want to see is really be able to see that the results, what happens with those results, if they're true or they're not. So I think that's where the trust has to be, and keeping that feedback loop, it always helps.
Yeah, and if I can respond to Mark as well, you mentioned the transparency. Like many things, it's not a nice to have anymore, but a requirement, right? The end users expect it, and to your point, Vanessa, they don't want to know the details. They just want to know, was it done properly? Is the right set of data being used? Are the results ethical? So it's almost mandatory now that the developer of ML models provide that transparency.
But to Vanessa's point, right, the transparency isn't necessarily how the models work. It's more whether the data is correct in their eyes, right? And you know, we get this question a lot, you know, with him, we see it all the time. And you know, one of my favorite examples is Google. You know, that we all use machine learning every single day, every time we search Google, and the models that are behind PageRank and the results that we see when we search Google, you know, we don't have to understand how PageRank works or how Google's models work. We just search for something and we get what we think are reasonable results. And so then we click through things, and we have the same thing, but sometimes in our customers, and I don't know if you know, I know we've been through a lot in all kinds of ways together, you know, but sometimes there's a fear of actually presenting the data that comes out of these models, because there's a fear that it's incorrect or that it's wrong. And there's like a, you know, sort of a paralyzing, you know, sort of behavior of like, no, we can't show them something that might not be right, as opposed to giving them what we think is the best thing. And then if they think it's wrong, we get their feedback and then we fix it. You know, any thoughts on that sort of human behavior of the fear of showing, you know, bad data?
I think there's a couple of things that I would like to pick up on, and it depends on the industry, right? But if I go to Netflix and I get a recommendation on a film to watch, that's fine. If they get it wrong, I can go to the next one and I can kind of quickly siphon through them. That's not having any material impact on anything really. But if you're looking at maybe my enjoyment, but if I'm looking at something that could be a safety issue, or if I'm looking at something that has a material change, then that's where you have to be a bit careful about just saying, well, how confident are you in the data and the outputs? And so, I've had people that I've dealt with that want to get into the detail and want to be able to understand it. But equally, I've got other people, and you have to gauge when you're interacting with people just how much level of detail you need to go into to have the explainability. But a lot of the time, if they're looking at the results and they actually then have confidence in those results and it's making sense to them, it's when you get that doesn't make any sense, and then they go back and do it the long way, and then they realize, actually, yes, that was some parameters that were really important. We just didn't have them in the model before because we weren't able to bring them in, because we were able to bring a lot more parameterization and be able to drop things that are not important and be able to cycle around and be able to have a look at everything in a bit more detail. So sometimes people are just more interested in the output. Some people are more interested in the detail. So it depends on what that data flow or expectation is for, and what the impact might be downstream.
And Andy, I think there's a human factor on both sides of it. To the end user, they'll always have a little bit of mistrust, so they want to see the transparency. To the developer, there's sometimes a fear of a punitive action if they expose what they're doing, and there should be a trust on that side as well, as share how you're doing it, and if it is wrong, you fix it, right? So I think there's a number of those factors that come into play in the whole life cycle of an ML engine.
And I think another piece that is really important is that it had been mentioned before about what you're using to get to build your models, what type of data. And if you're using even machine learning to clean up that data, like Tamer is a perfect example of mastering your data before you build a model for predictions and retention for your customers. It's kind of you're not going to get really, really good results if that data that you're putting in, it's not cleaned up, if it's not mastered. So there's a lot to it. And I think that when you're talking to the business and getting that trust and confidence is when you can come back, and when they say, well, what did you use for your model? What are the variables that you're thinking about? You can bring that into the table as well. Well, I'm using a set of customers, not duplicates of my customers, to build this model, because your results are going to be really, that's what it's going to make. Is like you can bake a cake, but if you add a double of flour, it's not going to come out great. So those type of things, I think it's really important to get that trust from your customers. And when you work more and more and more, you need to explain less and less, because if those questions are not there, which are healthy to have them, but it gets us to a much better place and a more efficient place when there's that trust built already.
So this is great, because it's like, there's this distinction of using machine learning to clean and organize the data versus using machine learning downstream to do predictive modeling or even prescriptive kinds of things, either analytical or operational. And you guys all have sort of, made that distinction in your organizations and have separated that out. But there seems like there are a lot of companies that haven't quite, separated out, well, this is machine learning for data engineering versus machine learning for data science. Any thoughts on what you're seeing there? Do you think people are making that distinction in your organizations, or do you think it needs more clarification?
I don't know.
Go ahead.
I think most organizations are not making that distinction, right? I do think it's largely machine learning is being applied kind of, based on the individual case-by-case scenario to say, hey, we have a problem, let's use machine learning. I'm not even confident that most organizations are really thinking through some of the points that we made around whether or not machine learning should be applied. So I think the idea that there would be a higher level kind of categorization of when and where this should be applied and what types of machine learning probably isn't happening. But I think it's more of a trial and error approach across many organizations, which at the end of the day, is not a bad. I think organizations will be able to learn based on the results that they get out of these projects, right? And so I think there is an opportunity for a higher level of governance to be able to provide some of those recommendations to the projects, to be able to say, hey, have you thought about these, key kind of factors before you start to head down this path, and what type of algorithm should you be applying for this specific problem? I think there's definitely an opportunity there, but I think this is a maturity stage that most organizations haven't gotten to today.
I think, Andy, too, is a machine learning application sometimes is not known to the end user. You mentioned the Google search, right? I mean, how many, do all people realize there's that engine behind the scenes? You think about, I was talking to a vendor just recently whose product searches for PII data, right? The end user doesn't care they're using an AI/ML engine to discover it. All they want to know is where the data is, right? So they're not asking the question; they just want to see the results. So I think ML may get a little bit of a white labeling over other functions sometimes.
Vanessa, I know that when you engage, like it's analytics and data together, right? Like you're delivering a complete product, right? So to most of your customers, I would imagine, and the business value you deliver, there's probably little or no awareness of where machine learning is, or right?
I think like it runs in parallels, because in parallel, one piece would be the cleaning, using machine learning to clean your data. That would be very foundational, and you have to push that as part of the data governance, data quality side of the house. On the other hand, you have the machine learning application where you're gonna want to add value to certain, like it's going to be an initiative that it's thinking about increasing sales by 2%, for example, and the model is going to help you to do that. But then we have to develop those models. We have to make sure that the data that we're bringing in, it's clean. So our customers may not know it, but on one side, we're pushing to do getting our data, let's say, fixed using machine learning as a foundation. But at the same time, every model we have to do it individually to get that good data into our model. So it is like, not everybody knows it or understands it, but everybody wants it. When you start talking about it, and they in your business will say, well, I want the right data. And then you start talking about how you're getting there. They're like, oh, we can use machine learning. So I think it's one of those things that just happen in parallel. A lot easier to do when there's going to be value added directly than when it's indirectly added, but both are as important, or if for them to happen. So it's a very interesting area of the application of machine learning, I would say.
Great. So, just, changing tracks a little bit and thinking about the, the applications, could each one of you just, talk a little bit more? You kind of hinted on this a little bit, like, the applications, and drill down a little bit, like what were some of the things that were most sort of challenging, in how you were using machine learning, and what are the things that were maybe surprisingly, positive or good or easier than you thought? Mark, you want to start?
Absolutely. So, I really think the challenge was that initial education around how they need to evolve, how our stakeholders need to look at this differently. The training and the process of providing feedback, right? So there was sort of an expectation that, we're bringing machine learning in, and we're immediately going to, see improved results without really a lot of engagement or feedback or interactions with our stakeholders, right? And so we need to educate them around, hey, this is a kind of ongoing process, and the more engagement, the more feedback, the better the data becomes, right? So, I think Graham talked about this, right? So the quality of the underlying data that was actually being fed into the model had a material impact on our results, right? And so we learned that we had to spend the time to really cleanse that data, get to a point where we were aligned around how we were actually looking at the data from an organizational perspective before we could really start to bring some of the value of machine learning, right? So those are a couple examples that were, I would say, challenges, and but like the results really spoke for themselves, right? I mean, the quality from a customer perspective was significant. I mean, we were seeing, improvement of over 30% within some of the kind of the aspects of the customer that we're working with, and delivering specific value, to our sales organization, for example, that they wouldn't have been able to receive in the time that we had actually delivered it. So, so some really good outcomes.
Yeah, something to add to that. I would say that where we've had the most success is when really building models and implementing them. It's a team sport. So when we've had the most success is when we really have a strong involvement from our business and from our technology side of the house and engineering and the data science team. So we're able to really use have clean data in that case, have it available pretty quickly, and also have that feedback and that during the development side have really work along with the business. So that's where we have been most successful. Also where we're able to automate and do that prescriptive side of things. So when we're able to have a model that then nobody knows is there, and we have done something like routing calls, for example, it really works out well for better prospects, and different things like that really serve our customers very well. And I would say that the biggest challenge is that education side, that skepticism that exists sometimes, and you have to go through in those cases go through smaller POCs so we can show the value to our business and get them on board, and really get their buy-in with something smaller before we go into the doing and building big things. So I think that's a challenge, but it's something that once you get that, then you don't have even the time to do so much of one certain group now wants everything, right? So it's then you have to find that balance. But yes, those are the two things I think that they're what we have faced in different businesses as well.
Graham?
Yeah, I think, in the energy sector, I've been with BG and British Gas, which is now Shell, and then BP and now Hess in the energy. And it's funny because every year it seemed to have this big data management initiative, and everyone was thinking about those meetings, and it was oh my God, and it was always cleanse the data, get it all standardized names and all. But then when you start to kind of think about what's happening nowadays, and this is just my experience maybe in the last 6 years, but it's gone away from that to thinking, okay, what's the business need in terms of a specific business problem? Okay, what data would make sense to input into that business problem? Okay, how do you actually get the data blended and cleansed on the front end, even before you do any of your model build? Because what people are starting to realize is that the models are only as good as the inputs. And if the inputs are not as good as you'd want it to be, and I'm thinking about simple things like filtering and dicing and slicing of your data when it's not standard across standard names in particular columns across multiple areas. So going across those different disciplines, and especially when you've got integrated projects instead of just one area of the business, you're actually needing to have that integration. It shows the gaps that really lie between the naming conventions on different parts of the business side. So I think it's more specific to business user need, and then relating it back to what the inputs are and really thinking about that flow and how you can help. I think there's also, just the last point I'll make on this is that when you do a successful project, then suddenly you get repeat customers. And what I mean by that is when somebody in the business is happy and they see that it's actually be transformational, not just for themselves, for the actual information that they're able to share, they're able to get stuff quicker back to their boss or even request, or even in the analytics themselves on that data, then suddenly they start speaking to their peer group and you get this embryonic kind of growth in particular areas. And that becomes overwhelming, right? It's like suddenly your one project goes to 10 ideas, and then suddenly you have to prioritize within work demand of what's actually going to be prioritized. Which ones are you going to be doing externally with vendors? Which vendors are you going to have? Which ones are you going to do internally? And there's all these CTO, CIO kind of, business budget discussions about which ones are going to be prioritized how. Well, I couldn't get out the CIO budget, I'll get out the business budget. Don't worry about it. But then you still have to have IT involvement for security and access to tables. And so it then becomes that work demand piece again. So it's that embryonic growth of repeat customers if you are business led, with the underpinning of the centralized kind of standards to be able to pull the data in on the front end to make sure that it's accessible and blended into curated tables, that we've seen the biggest kind of upscaling and usability and increase in users.
Well, it's so amazing to hear you guys talking about the same principles, right? Like this idea that you start with something small that's focused on delivering business value, and then you're successful there, and then that creates so much more demand that then you have a sort of a success problem, right? Of, okay, how can we support all these requirements from all these people that want to do similar things? And we at Tamer, we see that all the time where that works incredibly well. And it is hard, right? There is a success problem that you end up with, but if the alternative is kind of what, we've all been around long enough to see it, like, the first, rounds of MDM were these sort of like, if you build it, they will come sort of thing. And projects that took, years and years just to come up with a schema, not even talking to users about how it might be used or what might be done with it. And so like at Tamer, sometimes we get this question of like, and I've seen it in other tracks here, like, well, what is data mastery and how does that compare to MDM? And like, for me, it's like, it's just a couple of words that are used to describe, like, we're not doing that big waterfall schema development anymore. Instead, we're going to start with the questions people have in the business use cases, and we're going to work back. What sources do they need? How do those sources need to be cleaned? What do the models have to do in order to support them? But it seems like such a common theme, but yet, like, I think there are a lot of companies that really struggle with that tend to default to this waterfall behavior. Do you guys have to fight against that kind of tendency? Do you think this is counterintuitive to folks, especially in IT sometimes?
Yeah, definitely. It happens more than that we would like it to happen. I think something that it's very important is like that scaling part. You can do a small project, but when you're trying to really, a good example of this is segmentation. You could do a segmentation project in a small area of the business. The data is going to be a lot smaller, the data you're putting in, easy to handle. But when you're talking about maybe we're going to segment all our customers, then that's where you start having issues because you need to access a lot more data. And you're not going to be able to just do it by applying band-aids here and there. So then in that I think that step from doing the ad hoc little projects to really scale data science, machine learning, and AI in your company, that's where you have to be very, be successful as using the right tools, using the right models to get there. So I think that's where you have to be careful with on that step of being you're a victim of your own success, I would say, but then to keep it up, you have to be a lot more efficient and a lot more consistent as well.
I also think you kind of uncovered some aspects that aren't really specific to machine learning, right? Cultural dynamics of how an organization wants to operate, right? So this idea of identifying big projects that we're going to work on, and then we're going to deliver that throughout the rest of the year, even if we don't have all the different kind of usages of each of these different projects really well laid out, right? So I think this is that evolution that we're trying to really kind of manage through some of these organizations to recognize that incremental. I mean, this is principles of agile, principles of machine learning is to go small, learn fast, get feedback quickly, and then adjust, right? And so I think organizations are stuck in this kind of mindset of just establishing it at the beginning and then watching the results at the end. And so it's connected to a lot of other aspects within organizations. But the hope would be that machine learning can actually be a leader here, because you can really achieve some significant value outcomes here if you actually are tracking metrics and measuring the success and being able to actually communicate that out.
But there's a difference in the governance model with a machine learning engine versus other traditional applications, because it doesn't end. People forget machine learning keeps learning.
Yeah.
Right. And it may be great on implementation or even a couple of months afterwards, and then suddenly bad data enters the learning paradigm and the model goes haywire. We've seen too many examples of that where there's no governance to validate that the results continue to be correct post-production, and it could be very reputationally damaging to firms.
But John, do you see, like, this is one of my concerns, is that, oftentimes there's like, oh, well, we need to govern the model. So we need a group of people that are governance professionals, and they govern, like, like, and all of a sudden you have these people that are completely out of context for the consumption of the data, like governing the models. And, it's sort of like kind of what we had with the old MDM stuff, whereas the people that are really responsible for governance, ultimately are the consumers of the data, right? Like,
absolutely. In fact, that's why governance gets a bad, rap, right? Because it's assumed that, I mean, again, different paradigm, different end user, different use case, just to ensure that the model still operating. You don't want to introduce more complexity with the wrong sets of people, looking at things. The other thing, Annie, is, and I've seen this happen, where what success may look like isn't really success. So there's a classic example in the smart cities. In this one case, they wanted to improve the road surfacing. They were going to pull the data coming out of the smart cars with the shock absorbers hitting potholes and send crews out to fix the potholes. Worked great, except they were only fixing potholes in the affluent neighborhoods that had the advanced cars. And so, so what does success really mean? And you've got to have a broad perspective of that to really be successful with it.
Yeah, I think, the whole agile development is an interesting point. I've seen some of the successes that we've had in Hess is around creating user front ends that are very easy to use, and they're customer focused. So if they're wanting to gain access to particular information, then even that automation and being able to bring that blended view schema mapping into a common column name, being able to see what company X said, company Y said, if there's differences or there's similarities, being able to have that on a front end view that people are able to manipulate themselves, and then they start to become involved in the process. So I think having an easy user front end that's more agile development. And, I went to an innovation talk a couple of years ago, and I thought it was really strange, where it was like, always think small. And I thought, what do you mean by that? And it's like, how do you think about small incremental steps? Because I remember, completing really quickly some projects, 60, 70% solutions. And then suddenly the next idea. And then I look back over the year and I think, wow, what a step change we've made in the way that we actually do that particular workflow using machine learning. So I think it's those incremental small changes, rather than think about big projects, that then when you look back, you can see that you've actually made some big step changes moving forward.
Yeah, that makes a ton of sense. And, it's really, really remarkable. One of the other, topics that sort of come up, over the last few days here is, source data versus mastered data. And one of my really good friends, is Elena, who's now over at Roche, and she worked with us when she was at J&J. But she had this great quote, which was like, the source is not the master. And it was like this really strong statement that, like, any source owner thinks that their data is like the definitive thing, and their keys and their indexes are the primary. And and she was, it was an amazing thing. Can you guys talk a little bit about, source data versus like mastered aggregated data, and like where the trade-offs are, and how you're seeing, people remediate source data, that kind of thing?
So we get that question asked often. Is like, okay, what is the source for name, let's say? Something as simple as that. And as well, we don't have one source for name, because name could be originated when somebody's talking with on the phone with a customer, when they send an email, when they fill out an application online, or when they send a paper. So all of those go through different sources. And then you're not going to be able to say, okay, when I want to talk about name, I'm just going to go to one source and I have everything, because that's not the truth. It's originated in many places. So that's where mastering comes to be very important, because you're putting together, and you may have some information for a customer in one source, and for that same customer, additional information in a completely different source. So being able to master and then putting all those sources to talk to each other, I think that's where the trick is. And you cannot just decide that one of your sources is going to be your master source. You cannot do it that way. It doesn't work in practice, and more in very big companies that have bought other companies and have like merged and divide. And it's going to be very hard to do. So that's where it starts to get complicated.
Andy, I think to Vanessa's point, there are places where data mastered is necessary, maybe customer, because you don't want to have duplicate representations of customer. But if you think about the sources of data, and let's use the use case of, say, social media, I may want to pull data from all different social media sources where there is no master, because you're going to get different opinions in different venues. So I think there's a blending of the two. I don't think it's absolute in either case.
And I would also kind of indicate it starts to kind of, if I make the corollary to machine learning of when we're trying to engage end users or stakeholders, we don't want to teach them, the algorithms and getting into the data science specifics. We want to help educate them around why it made the choices that it made, right? I actually think it's similar to that. Like the choice around source and master is based on the specific use case you're looking to be able to achieve, right? And so I think we do kind of get into the sausage making aspects of things. Like, I don't know if it matters if it's source or master. I think the question is, what problem are we trying to solve? And what is the best way to be able to, what's the data set that makes the most sense to be able to achieve success here? And master may make sense because, to Vanessa's point, you have a lot of different sources, so you have to be able to aggregate it. But in some scenarios, I just need the data as from that initial source, because I'm going to act upon that. And so that's where I think there is a tendency to go too deep and just say, let's focus on the problem.
Yeah, we see this a lot in when people do spend optimization, and if the scope of their spend optimization matters, right? Like if they're doing spend op in one or two divisions, like all they care about is the supplier records and the transactions in those two divisions, and the rationalization across all the other divisions, it kind of doesn't matter to them, right? Now, at some point, they might want to extend it to the whole thing, but if like we did when we first started working with GE, 8 years ago, we wanted to do a complete view of, are we getting the best price across all of GE? Well, then we did need to sort of rationalize, dozens and dozens and dozens of ERP systems and all the supplier master tables and all the transactions across all these things. But many of our customers, they start with spend op in one or two divisions, and they don't need the whole big thing right off the bat. And so it's like the data that should be focused on is the data that matters for the use case.
I actually see a lot of, I see a lot of value when, if we're drilling a well somewhere and we've got header data and we've got it blended between different sources, there may be particular regions that are better from one source, like Mexico might be better from one and Brazil might be better from another, West Africa from another. So suddenly you're seeing that data quality come up. So that's where I see mastering being quite useful, because then you can have your data lineage back to source, so you know what your unified data table is from all of the different inputs, but you've also got the golden record, the one of choice that is the one that you, so if you wanted to override that or be able to see what the options are or feedback that, no, that's not right, then that gives the users the ability to be able to then have a kind of Hess view of that overprints everything else. So yes, you've got the ability of looking back at multiple sources, but you've actually got one of choice that you can say, okay, this is the one that we're going to be able to use that will be, it took me a long time to think about like all of those inputs and thinking about, the unique identifier for each table, and thinking about inputting that and how you blend them together, because when what is a well, is a scout report, it's got multiple wells coming in, you have to make sure that you're actually putting input into that is actually the same data and not different types of data, because it's not a unique record of choice. So getting those unique identifiers and being able to blend those between sources, then it means that you can kind of choose one column from one and another one from another, and then you kind of get an output that is far more accessible, and it's like what I call flat file analytics ready. It's all kind of those column after column. But nowadays, when I first started this like 6-7 years ago, oh my God, that's so many columns. Now it's like people want to have the ability of filtering and dicing, slicing with those consistent names on multiple columns, because they're putting everything into BI tools, whatever their package of choice is, and then being able to dice and slice that data for multiple use cases then makes that ROI of that particular project go up, because you're not just using it for one use case, you're using it across multiple use cases.
Yeah, so powerfully, so well said. And it's amazing when, as you're describing this, like the destination for those, for that clean, blended data, oftentimes are now these sort of modern database systems like, and Google very deliberately sort of called that thing big table, because they thought like sooner or later people are going to get to that point where they're going to put everything in one big table, or a lot of things in one big table, right? And minimize the dimensions, and so it's really amazing to see how that's evolved. Yeah.
But it amazes me still that a lot of companies call the same thing different things, if that makes sense. And it's frustrating because you're getting it from multiple people. I wish I could put it in global supply chains contracts. Can we call these things? Because they're subtle nuances that then the machine doesn't know that they're the same. So that's where you can have a categorization or a mastering to be able to allow that kind of consistency. But it's slightly frustrating, as you can imagine.
We did this project early on at Tamer with Siemens, and it got down, we're doing parts mastering, and it got down to these two people in these different divisions that the same exact part, and they insisted, right, that they weren't the same, because they called it something different. And all they were saying was, you just have to call it something different for me. Like, I'm not going to call it what that person wants to call it.
But I think the last point I'll say on this is that it does need that human guided input, because that's the kind of subject matter expert insight that you need to have. You can't make the decision as a computer. And I think that's where the benefit comes from machine learning and automation, is that suddenly you can have that kind of what I call feedback loop of doing a new transformation where it makes sense. It's then getting a standard column that then puts into the model. But it's that automated process to be able, for changes or new names, suddenly something changes, it comes through to the user on an email, rather than you having to go and check it and do whatever. The subject matter expert can then go into the tool, say, yes, that's the right cluster, or no, that needs to be in a different one. So it's how the data comes to the subject matter expert user to be able to keep those models up to date when things do change. So I think that is an important kind of input.
Yeah, and you can tolerate two names for one thing. Right, it's like, it's okay. They mean the same physical thing, but they're just two names. It's okay. Right? So one of the other things I wanted to touch on before we break is internal data versus external data. And I know that all of you sort of involved in blending lots of different kinds of data, both internal and external. Thoughts on how you see the mix changing, if it's changing, and if the ability to sort of more easily blend the data together enables you to add more external data. Any thoughts there?
I think that it's going to be, we're going to be using more and more external data, because you find all these companies that they are doing their own machine learning and getting the data for you. So it would be very hard for us in some cases to go and do that digging. And then sometimes you can get that data like already processed, let's say. But that's the problem that I see also with that, is the risk that you have of how that data is managed. That what is it, if it has been done the way you would do it morally, or if it's the right way or the wrong way. So that's going to be a little bit harder. So I think that we're in a very difficult place as we grow, because we want that data, but we also want people's privacy respected. We want to make sure there's no bias when that data is gotten. So we're going to have to be more careful when we try to use external data, but I see the potential of having really good quality external third-party data. So that's it's just finding that balance, I think.
Yeah, I think it depends on against what the use case is. If you think about finance for years, of course, Bloomberg, LSEG, Telecurs, all of the big players, the whole industry depended upon them as the source of that information. And the more that industry grows, the better data we're able to receive. But when you increase the players, you increase the possibility of inconsistencies. If you look at the use cases now in the ESG and data sustainability space, so many providers of carbon disclosure and so forth, but you question the validity of that data because they have different methodologies in which they track it. So, it's one of those good problems to have, but we're going to have to go through some rocky road for a while, I think. So I think the criticality of identifying the source, not to compare to the source discussion we just had, but, the lineage to where it comes from, right? Is going to be very important as we go forward with these in many cases, very good sources of external data.
Any other thoughts?
Yeah, I think the answer within Hess anyway is that, the external data providers are not going to go away, right? It's how do you get more strategic alliances, partnerships with them to get more out of what you're already spending with them. Normally we have an annual budget. We go out, they enhance their projects and products, and then suddenly, certain vendors kind of supersede the other ones. So you've got these ones at a point in time, they're the best, then the other ones, and then suddenly, and they're always wanting to create space for themselves in terms of going down particular avenues that maybe clients have asked them to do. So it's being able to make sure you're aware of what they're actually delivering to you, and make, and one of the things I get all the time is, hey, Graham, what's the best source for this? Or what's the best vendor that I can speak to for this? And it's not so much that data catalog, but it's about the relationships with the external data providers to know what their latest kind of offerings are and which road they're going down. And of course, then you've got new players that are coming in all the time. As players go away, new players adopt, they splinter off, form their own. Normally they're the same kind of companies, but it's just a different slant on the same thing. So it's how do you make awareness of where they're going versus what you're doing? At least my experience is that blending that between the external and internal then becomes important. The internal being a bit more structured suddenly becomes, an unstructured, mess of history, because the oil prices, you're probably aware that most people are, is that it's up at the moment. But a couple of years ago, it was uninvestable in oil, and it was like the dirty industry, and we can't, and now it's like all hydrogen and it's all energies of the future. So it's up and down. So how do you kind of do these projects when your commodity price is going from $100 to 40, in a year? How do you get that revenue earning and being able to say how much are you able to spend on external data providers versus internal data? But I think that, obviously there's going to be that mix moving forward where you have to continue to get the most out of those external data providers, but also there's the case for getting more out of your internal data. Just how much of your data is captured and actually being used for specific business problems. So how much storage, which projects, how many bots have you got? Are they still being used? Is it for niche product areas? And then suddenly they're like kind of lost, or which ones are the big ones that are being used a lot?
And just to add on to this, I would say the opportunity for additional external and third-party data is just going to continue to increase, right? So I don't think we, any of us should look away from that. I think it's and this is another machine learning kind of use case opportunity, right? Is that identifying the which sources are higher quality than others, right? And it's a use case that we've looked at. So it's just a matter of because it does allow you to scale to be able to kind of quickly assess which source is actually providing the right level of quality, and then you can prioritize and make decisions off of that. So I think it's definitely a big opportunity for everyone to continue to leverage.
That's great. Well, this has been a fantastic discussion, and obviously sort of appreciate all the incredible work that each of you have been doing in your respective organizations. And John, appreciate everything that EDM Council is doing very broadly, across everyone that works with data. It's really, incredibly impactful and very, very, very powerful. We covered a lot of ground in the session and talked about a lot of great things. Like for me, some of the highlights, include this idea of, start with the use cases and the business case and work backwards into the data that matters the most, and use that to make sure that the models you're building are relevant to helping, your company save money, drive growth, or reduce risk. And this idea of you start with these smaller POCs, these smaller projects, and build your infrastructure on the success of those in an agile way. I think that's a very, very powerful principle. This idea that, I love what Vanessa said, building models is a team sport. It's fantastic. And, in the early days of the academic data tamer project, we did this thing at Novartis, and we took a team of 12 curators that were dedicated full time, and we ended up asking questions to help curate the data to thousands of people. And at the end, Mark Schreiber, who's now over at AWS, he said, listen, I feel like the entire organization is curating our data. And, I think that's, there's a sort of a spirit behind this, which is that data is generated in lots of different places and consumed in lots of different places, and should be curated across the entire organization. And you know, there are a lot of experts that can have a huge impact on the quality of data for people, and also there are lots of small places, nodes in the network that can help improve the quality of data. And you know, so you guys have done such a great job today. Thank you so much for your time, and really, you know, deeply appreciate the effort. And I will wrap up now and look forward to our next session, which is in 30 minutes. And hope that you're all having a great day today at CDOIQ. And for those of you that are coming to dinner with Tamer tonight, look forward to seeing you all there. Thanks.
Thanks, Annie. Thanks, everybody.
Thank you so much.
Cheers.
Have a great
Bye.
day. Bye.